The first 30 minutes of the session are excellent. The assistant reads your code. It follows your architecture. It writes a function you would have written yourself. 2 hours later, something is wrong. It suggests editing a file it already edited. It ignores the constraint you set in your very first message. It offers the same fix that failed 20 minutes ago with complete confidence. Most developers conclude that the model got worse. The model did not change. Not one weight inside it moved. What changed is the thing you handed it. This video is about that thing and about how it breaks. Start with the part that is easy to miss. The assistant has no memory of your conversation. Nothing persists between your messages. When you press enter on turn 40, your client does not send turn 40. It sends turn 1, turn 2, turn 3, and everything after, all of it, as one flat block of text. Every message you wrote, every file the assistant read, every command it ran, and every result that came back. The whole transcript is rebuilt and resent from scratch on every single turn. That block has a size limit. The limit is called the context window, and it is measured in tokens. A token is 3/4 of a word, on average. Modern coding models accept windows of 200,000 tokens or more, which sounds enormous. So the window is not really a memory at all. It is a workspace. You rebuild that workspace and hand it over completely every time you speak. The obvious response is to make the window bigger. Vendors did that. It helped less than expected. Capacity and usable attention are different things. Inside the model, every token is compared against every other token. Double the number of tokens and you quadruple the number of comparisons. That work is spread across the same fixed amount of model. Measured retrieval accuracy drops as the window fills, well before the window is actually full. You can observe this yourself without any special tooling. On turn 60, ask the assistant to recall an exact detail from turn 4. Position inside the block matters too. Material at the very beginning and at the very end is used more reliably. Material in the middle is used less reliably. This behavior has a name that is worth remembering. It is called lost in the middle. There is a practical consequence for a long session. The instruction you wrote at the top an hour ago is no longer at the top. It is buried in the middle of a very large block of text. It is still present. It is simply no longer prominent. 4 distinct things go wrong inside a filled window. The first is context rot. Rot is accumulated junk that is still being resent on every turn. You read a file. You then edit that file. The old version stays in the transcript, so 2 versions of the same code now sit in the window. A test run prints 400 lines of output. Those lines stay. You try 3 approaches and abandon 2 of them. All 3 stay. Nothing in a transcript is labeled as outdated. The second failure is context poisoning. Early in a session, the assistant invents a method signature that does not exist. Perhaps it writes a repository method with a parameter the real class never had. You do not notice because everything near it is plausible. That invented line is now part of the transcript. On the next turn, the entire transcript is sent back. The model then treats its own earlier output as established fact. It builds on the mistake. It cites itself as the source. The third failure is context distraction. As history grows, the model has an enormous quantity of its own previous output sitting in front of it. Imitating that pattern is easier than reasoning about your new request. So it produces something shaped like the last 5 answers. You ask for a different approach and receive a variation of the old one. The behavior looks like stubbornness. It is closer to pattern matching against a very loud transcript. The fourth failure is context clash. On turn 3, you said to use the existing validation utility. On turn 40, you said to write the validation inline and skip that utility. Both sentences are now in the window. Both appear equally current because a transcript has no concept of superseded. The model holds 2 valid instructions that directly contradict each other. Sometimes it picks one of them. Sometimes it produces an answer that half satisfies both, which is the worst of the 3 outcomes. None of these 4 failures throws an error. That is the part that matters most. A poisoned context does not produce a stack trace. It produces a clean, well-structured function that calls a method which does not exist. It reviews well. It fails at runtime. A clashing context does not warn you. It produces code that follows one of your two rules and quietly drops the other. Rot does not announce itself either. It just makes each answer slightly more generic than the last. The output stays fluent. It stays confident. It stays plausible. So the natural conclusion is that the model is weaker today, or that the vendor changed something quietly. The session is what changed. There is a name for managing this deliberately. It is called context engineering. It is not the same thing as prompt engineering. Prompt engineering is the craft of writing one good instruction. Context engineering is the craft of deciding what occupies the window at every moment of the session. The same four decisions repeat constantly. What is allowed to enter the window? What is allowed to stay? What gets removed? What gets compressed into a summary? Nobody makes those decisions for you. The client appends everything by default, and default behavior is exactly what produces the 2-hour session that stops working. Your real role in a long session is editor. Now, look at what you put into that window on purpose. Take one task, add caching to the user lookup. Asked that way, the assistant has to guess. It guesses the library. It guesses how long an entry should live. It guesses whether a stale read is acceptable. Every guess becomes a stated fact inside the window. You then spend 3 turns correcting guesses you invited. Ask the same task the other way. Name the interface the code must satisfy. Name the expiry you want. Give one example call and the result it should return. Then name the non-goals, the things it must not change. The second request is longer to write. It also produces the shorter session because the guessing never happens. There is a stronger version of the same idea. Do not describe the function you want. Supply the shape it has to fit. Write the call site first. Write the test first. Give the assistant both of those, and only then ask for the implementation. This changes the problem it is solving. Without them, it is inventing an interface and an implementation at the same time. With them, the interface is already fixed, and only the body is open. A fixed target also gives you a check that does not depend on reading the answer carefully. The test either passes or it does not. This costs a few lines up front. It removes a whole class of correction turns later, and correction turns are what fill a window with contradictions. So here are the tactics, each one tied to the specific failure it treats. Run one task per session. When the task changes, start a new session instead of continuing the old one. A fresh window contains no stale file reads and no abandoned approaches. That treats rot and distraction directly. Starting over feels wasteful. It is not. Second, externalize your state into a file. Keep a plan document inside the repository. Put the current constraints in it, the steps that are finished, and the steps that remain. Ask the assistant to read that file and to update it as work progresses. Truth now lives on disk. You can edit it there. An old version is genuinely deleted, not pushed into the middle. That treats clash because a plan file only ever has one current version. Third, retrieve deliberately instead of dumping. Loading an entire folder feels safe. It is the most common way to fill a window with noise. Load the 2 files that actually matter. Add a third only when you find that you need it. Less material in the window means more attention on the material that counts. That treats rot, and it keeps important code out of the weak middle region. Fourth, use position on purpose. Restate the active constraint at the end of your message, not only at the top. The end of the block is a strong position, and you control it on every single turn. One closing sentence naming the current rule is worth far more than the same rule stated an hour ago. Fifth, compact the history. Most tools can replace a long transcript with a short structured summary. Some do it automatically once the window fills. Reclaiming that space removes rot in a single action. Then read the summary before you continue. Check what it dropped, because a summary written by the model is a lossy copy that the model chose. Sixth, isolate narrow work. Give a self-contained task its own clean session and bring back only the result. A long investigation can run inside one window and return 5 lines into another. Last, handle poisoning correctly. Never argue with a wrong claim inside the same session. Correcting it adds more text and leaves the original claim sitting in the transcript. Restart or edit the message that introduced the error. None of this is worth taking on faith. Measure it. 2 numbers are enough, and both are already in front of you. The first is whether the task finished without you correcting it. Count that by hand across a week. It is a tally, not a benchmark. The second is tokens spent for each completed task. Every provider reports token usage on every call. Add it up per task, not per call. Run 1 week the way you already work. Run the next week with 1 task per session, with state kept in a file. Then compare the 2 tallies. If the numbers do not move for the work you actually do, keep your old habit. Measure your own sessions instead of trusting anyone's claim, including this one. Return to the 2-hour session from the beginning. The assistant did not get dumber. The workspace got crowded. Every stale file read was still being resent. So was every abandoned attempt. So was every superseded instruction. All of it competed for the same attention as your actual question. The context window is a workspace that you manage. It is not a memory that manages itself. Once you see it that way, these fixes stop looking like tricks and start looking obvious. And the responsibility moves. The quality of what comes back is downstream of what you chose to keep in the window.